To begin, I'm going to go over the basic anatomy of the uterus. In this diagram, we have the ovaries, the fallopian tube, the uterus, the cervix, and then the vagina. The uterus, what we're going to be focusing on, is one of two major layers. So the red is going to indicate the endometrium, which is going to be the inside lining, and the green is going to be the myometrium, which is going to be the muscle. But for today's lecture, we're going to be focusing on the red, which is going to be the endometrial layer. Next, I'd like to back up and show that we have three different phases of the ovarian cycle. So we've got the proliferative phase, the secretory phase, and then the menstrual, and I have the days listed as well. And then expand even further what each one of those phases is. And this is where the anatomy is going to come in handy. So we're going to begin with days 6 to 16. So the uterus has already shed the endometrial layer, and we are beginning the cycle anew. So what happens? Well, the main player is going to be estrogen, and estrogen is going to cause the stromal cells within that endometrial layer to proliferate. So that endometrial layer is going to swell. And then also, as it swells and grows, blood vessels will grow to support the endometrium. Next, later on in the cycle, another player, progesterone, is going to be the hormone that causes the swelling and the development of the endometrial layer further. So the estrogen is going to proliferate, and then while the progesterone is going to more develop and get the endometrial layer ready for implantation by the ovum. And as a side note, the vessels do become more tortuous. Finally, if there is no implantation by the ovum, you're going to move on to the next cycle, which is going to be the menstrual cycle. And during the menstrual cycle, what will happen is the corpus luteum, which is going to be in the ovary, and I'll get to that later, is going to involute, meaning it's going to pretty much fade away, which will decrease your estrogen and progesterone layers. When that happens, you're going to get a shedding of the endometrial layer of the uterus. And that's going to happen on day 1 to 5 in the cycle. Next, we're going to cover the hormones, mostly progesterone and estrogen, but also there are a few other hormones that play into this cycle. So, just as a recap, you have 3 different phases. The proliferative, which is going to be controlled by estrogen, which is going to grow the endometrial layer. Secretory phase is going to be the development of the endometrial layer, getting it ready for implantation by the ova, and that's going to be controlled by progesterone. Then finally, the menstrual phase, where you have a lack of estrogen and progesterone since your corpus luteum, which we'll get to, has involuted. And when you have a lack of estrogen and progesterone, then your layer is going to shed, and then the endometrial layer is shed, and you can start anew again. To understand the hormones, we're going to go over the HPG axis, which is just going to be the hypothalamus, the pituitary, and then the gonad, in this case the ovary axis. So the hypothalamus is going to secrete gonadotropin-releasing hormone, which is going to go to the anterior pituitary, which will secrete luteinizing hormone and follicle-stimulating hormone, which will act upon the ovary. The ovary is then going to go and produce estrogen, and then also sometimes progesterone. And when you have excess estrogen and progesterone, you're going to have a negative feedback, so it's going to stop the release of gonadotropin-releasing hormone and luteinizing hormone. So that way you don't get too much of this. That's going to be a typical scenario. However, mid-cycle, about day 12, you're going to reach a threshold on the amount of estrogen. Typically, estrogen is going to negatively inhibit, negatively feedback into the hypothalamus and the anterior pituitary to stop these hormones. However, that day 12, once you have an estrogen threshold that's released by unknown mechanisms, estrogen is going to actually positively feedback upon the hypothalamus, which is going to be opposite of negative feedback. So positive feedback is going to increase the amount of gonadotropin-releasing hormone, and that's going to cause the LH surge to happen. And once the LH surge happens, then you're going to start producing more progesterones. So now that we've covered the HPG axis, we're going to go over a little more expanded view of the hormones. Okay, so now we're going to go to an expanded version. So we have our HPG axis that we just covered, Now let's move on to hormones. And you may have seen something similar to this, which is going to be one of those multi-hormone charts where they're all superimposed on each other. But we're going to start by one at a time. I didn't label, but this is going to be estrogen, the hormone that we're going to be specifically looking at. Just without looking at the blue, you can tell that this y-axis is going to be the hormone concentration. So as you go up, it means that there's going to be more hormone within the bloodstream. And finally, on the x-axis, we've got the days of the cycle. So a typical menstrual cycle is going to be 28 days. And starting at day 0 is going to be associated with the menstrual phase, which we covered in the uterus. That's going to be the bleeding phase. So about day 0 to day 5, day 1 to day 5 is going to be the menstrual phase. Then you're going to go into the follicular phase. And then finally, day 28 is going to signify the end of the cycle. So now let's take a look at the hormone within here. So as we go over, it means that you go days in the cycle. I did mention before that day 12 is going to be the day of approximately your LH surge. So I did mark that because that is going to be a significant day to know. And then also likewise, the higher up we are, the more hormone. So we've got estrogen. So initially, you have low amounts of estrogen, but as your follicles, which we'll cover later, as your follicles develop, they're going to secrete more and more estrogen. Eventually, levels will peak and go above threshold. So here, estrogen is being produced, and it's inhibiting the LH-FSH. Eventually, you will reach threshold, and once you get above that threshold, it's going to go into positive feedback. So you're going to have a surge of that LH, and that's where the LH surge actually comes in. Estrogen levels will drop, and eventually you'll have higher levels of FSH and LH, which we will cover later, and that's why we'll see an increase in estrogen. For the time being, just realize pretty much from day 0 to day 12 is the important part. I will get back to the estrogen curve. So realize that there are low amounts of estrogen early in the cycle with increasing amounts early on. So we just covered estrogen, and now we're going to be dealing with progesterone, which I'll label as PG. With estrogen, we noticed that there was an increase early on in the beginning of the cycle, which is going to proliferate that endometrial lining, if you can correlate that back to the uterus lecture. So as you increase the estrogen, your endometrial layer will develop. Now we're going to be dealing with a different hormone, which is going to be progesterone. So for progesterone, we actually don't see progesterone until later on in the second half of the cycle. So notice that the LH surge is still going to be day 12, and after your LH surge, you're going to get the rise in progesterone. While your endometrial layer is developing with the estrogen, now that we have progesterone, remember that it's going to pretty much mature that endometrial layer and cause the secretory phase of the uterine cycle. So now, later on, we're going to have a rise in progesterone due to that LH surge. Third hormone that we're going to look at is going to be luteinizing hormone, or LH. And as you can tell here, we have the 12-day LH surge. So let's get to day 12. Starting at day 0, we have low amounts. And with the increasing estrogen, we'll have even less amount because of that negative feedback on the HPG axis. Then all of a sudden, we hit that threshold that I was talking about with the estrogen threshold. And that's going to change it to a positive feedback. And that positive feedback is going to happen approximately day 12, giving us this LH surge. So it's going to be a very large spike in the amount of luteinizing hormone within the bloodstream. And then the later half of the cycle, the LH levels are going to decrease, and then the cycle will start over. Lastly, the fourth hormone that we're going to cover is going to be follicle stimulating hormone, also known as FSH. So we can tell here that we have low amounts of FSH, which are going to stimulate the estrogen, and as estrogen increases, that's going to negatively feed back into the HPG axis. So we're going to have decreasing levels, so increasing estrogen, decreasing FSH. That comes at no surprise. Then we have the threshold reached by estrogen causing that LH surge, which is also going to cause a slight increase in FSH as well, mostly LH, but some FSH. And then again, the second half of the cycle, we will have negative feedback happen again, so we're going to have decreased amounts of FSH. Now, I added two hormones together, so we're getting close to the big picture. I have LH and FSH, LH being the LH surge in blue, FSH being black. Note that their concentration levels within the blood are approximately the same as you complete the whole cycle, except for this day 12, where you're going to have an disproportionate amount of LH to FSH. Otherwise, for the most part, the hormone concentration within the bloodstream is going to be about the same. As you have increasing amounts of estrogen, which we'll get to, you'll have decreasing amounts of LH, FSH levels early on in the cycle. And finally, now we get to the mess. This is what most textbooks and internet pictures will show. I took it step by step, hoping to separate some of this, and I do have it color coordinated. However, it does get messy. So let's walk through this in a stepwise approach. So the red line is going to be estrogen, and this is going to be where we're going to start looking. So we have increasing amounts of estrogen, and I'll get to the reason why that is, why we have estrogen being produced. Typically, it's going to be that LH, FSH that produces the estrogen. However, you're having estrogen produced by a different source, and that is going to be causing an increase. And as you increase it, you're going to have negative feedback upon the HPG axis. So this black and blue are going to be LH, FSH. So they're going to decrease. You're going to have an inverse relationship. As estrogen increases, LH and FSH will decrease. I didn't draw in the threshold, but I've talked about it a few times. There's our imaginary threshold line that reaches about mid-cycle, so about day 12. Estrogen switches to positive feedback, which is why you get this large LH and slightly large FSH spike at about day 12. It's due to that positive feedback. Then the system will switch back to negative feedback. So this high amount of LH and FSH is actually going to go back to the negative feedback. So with high amounts of LH, FSH, that'll cause, and we do know that high amounts of LH and FSH will cause an increase in estrogens, and specifically the LH will cause a high increase in progesterone. So with these high levels of stimulating hormone and luteinizing hormone, we'll have an increase in progesterone and an increase in estrogen that we'll see in the second half of the cycle. Conversely, that high amount of progesterone and the high amount of estrogen, like I said, switched back to the negative feedback again. Just about the day 12 region is going to be a positive feedback. Everything else is going to be negative, what you'd typically think. So we have the high FSH and LH surge, and that's going to cause an increase in estrogen and progesterone. But the estrogen and progesterone high levels will lower the LH, FSH levels back down to normal. And ultimately, which I will talk about later, your estrogen and progesterone levels will finally drop, and the cycle will start over again. So we've covered a lot up to this point. Just in recap, we covered the uterus and the uterine cycle. We covered the hormones, and we covered the HPG axis. Now I'm going to try and piece everything together. This is the part where I wish my teachers had gone over this and tried to piece everything together. I've been presenting the different pieces, but this should be the overall picture. So we're going to start in the very beginning. So assuming we just shed the endometrial layer, now we're going to start over. So what happens? Well, we have the gonadotropin-releasing hormone, which is going to pulse, and if you want, you can remember this. High-frequency pulses is going to be LH, low-frequency is FSH. Just realize that the GnRH pulses can determine whether or not more LH or more FSH is going to be produced. So you're going to have gonadotropin-releasing hormone produced, and early on in the cycle, you're going to have follicle-stimulating hormone more than LH, luteinizing hormone. So, like the name implies, follicle-stimulating hormone stimulates follicles. And the follicle is going to be within the ovary, and that's what's going to actually produce that mature ovum. So typically, FSH will stimulate anywhere from 6 to 10 follicles to develop within that ovary. We all know that 6 to 10 follicles don't get fertilized, so we do know that these follicles, 6 to 10 of them, produce estrogen. Estrogen levels rise, which is going to negatively feed back on the FSH-LH levels. So with the rising estrogen, we'll have decreasing FSH and LH. Eventually, with the decreasing LH-FSH levels, you're going to have less FSH and LH that can act upon these follicles. So less FSH, LH on the follicles. The most mature follicle at this point is going to take over. So all the other ones are going to go off and die, but the most mature follicle will take over. And that'll keep producing estrogen. So that's why our estrogen levels keep rising. It's because this mature follicle now is still producing the estrogen levels despite the negative feedback on FSH, LH. And then also, with the increasing estrogen levels, we're going to go back to the uterus and realize that the endometrial level had already been shed, and now we're starting to build it back up again, getting it ready for fertilization. So we have one follicle, and our endometrium is starting to develop. Now we can move over here. We've got decreasing LH-FSH levels, which I already mentioned, due to the estrogen levels increasing. So we've got the survival of the fittest. We've got our one follicle that is the most mature, ready to develop. So finally, we reach threshold. That's going to cause positive feedback. We've already gone over positive feedback. So we have increasing LH-FSH levels. Next, that increasing LH-FSH levels, remember I said in step 1 that our gonadotropin-releasing hormone can switch between LH and FSH predominance. Now we have LH predominance, so we have an increase in luteinizing hormone. So now we have our LH being produced, which is going to be that LH spike in the cycle. That LH spike correlates with the ovum being excreted from the follicle. So now our follicle just spit out the mature egg, and their ovum is now in the fallopian tube. That follicle is going to turn into the corpus luteum. So LH causes the ruptured follicle, which just released the ovum, to become the corpus luteum. And that's going to be an endocrine hormone, an endocrine gland that's going to be a temporary gland within that ovary. That's going to produce estrogen and progesterone. As a reminder, the progesterone is going to be secreted primarily due to that LH surge, and that's going to cause the differentiation and maturation of that endometrial layer. While the estrogen proliferates it, the progesterone is going to pretty much mature that endometrial layer. So when the ovum that's excreted into the fallopian tube is ready, when it gets into the uterus, the progesterone will have primed that uterus endometrial layer for implantation. So that brings us to the topic of implantation. And we'll move on to the next part now. So our progesterone primed our uterus. Our ovum now is going to be entering that uterus. Whether or not it implants is going to be the next question. So let's say that a sperm met that ovum. It is now fertilized. We are going to go on to the yes, and then let's say the sperm did not fertilize it. We would be going into no for implantation. So let's start with the no, because that's going to be the primary thing that most women encounter. So on a typical cycle, you're going to have no implantation. So what happens? Well, our corpus luteum is going to be producing estrogen and progesterones. That is going to negatively feed back upon the LH and FSH. Our positive feedback was just during that day 12 region with the LH surge. So now, with our high levels of progesterone and estrogen, we're going to have negative feedback on that LH-FSH by the corpus luteum hormones. So as your LH and FSH levels drop, this causes an involution, which pretty much meaning death of the corpus luteum within that ovary, and the corpus luteum is going to decrease its hormones, which are estrogen and progesterone. Finally, third bullet point here, eventually the estrogen and progesterone levels drop low enough and then negative feedback stops, so you're going to have an increase in LH, FSH slightly, which will elevate your estrogen and progesterone. Not created by your corpus luteum, but created by the ovary instead. So now, that's if no implantation occurs. Now let's move on to yes, implantation did occur. So that ovum, fertilized ovum, is going to implant within the endometrial layer that's been nice and primed by the progesterone. Human chorionic gonadotropin hormone is going to be produced by the placenta, and that's going to maintain the corpus luteum temporarily. Initially, our ovum just implanted within the uterine wall. As soon as it implants, it's not able to produce enough hormones to maintain itself. So that's why it produces, it does not produce, part of the primary embryo, placenta. It's going to be called the syncytiotropoblast. It's going to initially create this the HCG hormone, and that is going to act upon the corpus luteum, which is going to be in the ovary, and keep it around for at least 8 weeks. Finally, your placenta after 8 weeks is going to make enough hormone to sustain itself. Specifically, the part of the placenta is going to be the syncytiotrophoblasts. And after 8 weeks, you can make it your own hormones, so it doesn't need the corpus luteum around, and that is going to involute as well. So if you stick with me for one more minute, I'm going to try and summarize this whole cycle, which we covered involving the uterus, hormones, and axis. So let's see if I can get through this whole cycle in 1 minute, touching upon the major points. So to begin, we're going to have our gonadotropin releasing LH-FSH. That LH-FSH is going to stimulate the follicle. Our follicle will produce estrogen. The most mature follicle will survive. It'll keep producing estrogen. Eventually, we'll have our FSH, LH levels drop because of negative feedback. Our estrogen levels finally reach threshold. They're going to create a positive feedback LH surge. That LH surge is going to cause an increase in progesterone. That's going to finally develop our uterus. Meanwhile, our gonadotropin releases LH now instead primarily. Our follicle is now the corpus luteum that is going to produce estrogen and progesterone. Now we get into the point of whether or not it's implantation or not. If it is implanted, HCG is going to be the major player. It's going to keep that corpus luteum around. If not, if there's no HCG, the corpus luteum will die off and the cycle repeats.